Okay. So last time, sinimulan natin yung discussion sa electricity with yung concept ng charges and electromagnetic induction. At ngayon, and then ang ginawa natin sa remaining time nung sa lesson ay nag-solve tayo ng mga problems. Itong mga problems na sinusolve natin sa book ay yung sinusolve natin sa klase ay so far mga problems na nandoon sa book. Okay? After this problem, magdi-discuss na tayo ng mga examples na galing sa end ng chapter. Okay? Ang isang concept na nakalimutan kong sabihin sa inyo last time is yung mga charges na pinag-aaralan natin ngayon ay hindi gumagalaw. Okay? So, in other words, hindi pa natin kino-consider yung velocity ng charges and kung anong nangyayari pag nag-move yung mga charges na yan. So ngayon, we're just exploring yung idea ng charges that don't move or yung tinatawag na static charges. Okay? And yung mga examples na ito ay yun nga, mga examples ng mga charges that don't move or mga static na charges. Okay? So, we ended up last time dun sa example ng two positive charges, Q1 equals Q2, equals to 2 microcoulomb. Okay, na located at x equals 0, y equals 0.3 meters, and x equals 0 and y equals 0.3, negative 0.3 meters, respectively. Okay. So yan yung figure ng location ng unang dalawang charges. Okay. So, ito at saka yan. Okay. And then there's a third charge and gusto nating malaman kung ano yung magnitude and direction ng total electric force of these two charges Q1 at saka Q2 on the third charge na Q. Okay. Yung third charge na yan ay merong charge na 4.0 microcoulomb and located siya at 0.4 meters, y equals 0, okay, as shown in this sketch. Okay. So ito yung mga charges natin. Ito, positive charge, ito. And then yung third, ay nandito. Okay. We started our approach sa pag-solve ng problem na to by simply taking a look at yung effect ng charge Q1 on Q2 at nakita natin na ang ginagawa ng Q1 sa hindi Q2 kundi Q, ay pinupush niya away in this direction yung charge. Okay. So yan yung force 1 on Q. Okay, and kaya niya pinupush away kasi pareho silang positive charge at nagre-repel sila sa isa't isa. Ang ginagawa naman ng Q2 on Q is similarly pinupush niya away papunta sa direction na ito. Yung Q kasi yung Q2 ay positive at yung Q is also positive. So nire-repel niya. Okay, and yan yung force na yun is described by this quantity F2 on Q. Okay, well, dito nilalagay ko FQ2 on Q. Okay. So yung magnitude nung forces na yon ay na-solve natin using itong equation na ito. F is equal to K times Q1Q over R squared, where R is the distance between 1 and Q. At yung distance na yun, nakita natin to be 0.5 meters. Okay, and yung magnitude ng force na yun is 0.288 newtons. Similarly, yung force na in-exert ng Q2 on Q is given by Q times Q2 times Q over yung distance between Q2 at saka Q, which is also 0.5 meters. Okay, and yung force na yun was also 2.88 newtons. Okay. Then, yun yung step 1. Ang step 2 is to break this force into its component forms based dito sa Cartesian coordinate system na dinefine natin, yung x and y na axis. Okay, to be able to do that, ginamit natin yung equation na ito. So we have this equation, okay, for the force, the x component of the force of Q1 on Q, this equation for the y component of Q1 on Q, this equation for the component along the x-axis ng Q2 on Q, and this equation for yung component along the y-axis ng Q2 on Q. Okay, may mga tanong ba in relation to these tawag dito, to this derivation? Okay, na klaro ba lahat? Klaro ba sa inyong lahat kung paano nakuha yung mga equations na yan? Okay, good. Sige. So now let's solve yung components ng mga yan. Okay, so tignan natin yung muna yung component along the x-axis ng Q1 and Q. So, by the way, bago natin makuha pala yun, alam muna yung cosine alpha at saka cosine theta. Okay, so we defined alpha here. Okay, dito sa angle na ito. Okay, but based sa geometry, okay, yung alpha, yung angle na alpha is also this one, right? Okay, so this angle is equal to this angle base sa geometry. And which means na yung cosine alpha ngayon yung cosine alpha ay equal sa ay makukuha natin based on this triangle here. Okay? And if this is the angle alpha, then that means ang cosine alpha is adjacent over hypotenuse. Ang adjacent is 0.4 meters at ang hypotenuse is 0.5 meters. So pwede natin ilagay na adjacent over the hypotenuse. So yan yung cosine alpha. Similarly, yung sine alpha is the opposite over the hypotenuse. So ito yung opposite side ng triangle and ito yung adjacent side ng triangle. So that's 0.3 meters over 0.5 meters. Okay. We can derive the same relation if we use this alpha instead. Okay. From geometry, this alpha is equal to this alpha here. Okay, itong alpha na ito ay equal sa angle na ito. So this is also the angle alpha. Okay, and we use this triangle instead. But yung triangle na yan is precisely this triangle. So we derive cosine alpha and sine alpha in the same way, even if we use this lower right triangle. Okay. So now, pwede na natin isolve yung Q1 on Q, yung x component na yan. Okay. From this equation, we know na force Q1 on Q is 0.288 newtons. And we know na yung cosine alpha is 0.4 meters divided by 0.5 meters. So this gives us 0.230 newtons. We can also solve for the y component of the force on Q by Q1. So this is 0.288 newtons, okay? And here we multiply it by sine alpha, so it's 0.3 meters divided by 0.5 meters. And this will give us 0.173 newtons. Okay. Sorry, Q1 on Q. Okay, yung Q1 on Q, sige, balikan natin yan mamaya. Okay, now we can also solve for F of on Q by Q2 along the x-axis. So that's 0.288 newtons times yung cosine alpha, 0.4 meters divided by 0.5 meters. So equal din yan sa 0.230 newtons. And then yung FQ2 on Q along the y-axis, 0.288 newtons. 0.3 meters divided by 0.5 meters equals sa 0.173 meters. Okay, so mga magnitudes lang yung tinitingnan pa natin dito so far. Okay, now if we refer to the figures here, we can now add in yung unit vectors or include yung unit vectors. So yung F1, FQ1, yung Q1 on Q along the y-axis is actually negative. Okay, so we can write here a negative J hat. Okay, J hat tells us na it's along the y-axis, and yung negative sign tells us na the vector points toward the negative y direction. Okay. Yung x component nung vector ng Q1 on Q is along the x-axis and it points towards the positive x-axis. So we write plus I hat. Okay. Then we also write yung the vector notation. Okay. Now, along yung Q2 on Q naman, along the x-axis, points towards the positive x-axis. And it's along the x-axis, so we write positive I hat, and then yung notation para maging vector siya. And then yung y component ng Q2 on Q is is along the y-axis and points towards the positive y direction. So lalagay natin dito is plus J hat. Okay. So the only thing left to do now is to sum all these vectors. Okay, kasi we're looking for the magnitude and direction of the total electric force. So, syempre, ang isasum muna natin ay yung mga x components. So, isum natin yung x components. Okay, so this will give us F Q1 on Q along the x-axis plus F Q1 on Q as Q2 on Q along the x-axis. Okay, so this will give us 0.288 newtons. Ganitong gawin natin para Consistent tayo sa colors. Ginagawa natin sa Q1 dito. Then, ito. Blue. Okay. So, this will give us, mas mabilis siya ito magpura. This will give us 0.2288 newtons positive I hat plus 0.288 newtons positive I hat. Okay, or equal to ngayon sa 0. Sorry, bakit 288? Bakit 288? 230. Okay, so this gives us 0.230 newtons positive I hat plus 0.230 newtons positive I hat. And this gives us 0.460 newtons positive I hat for the net force along the x-axis. Okay, along the y-axis, we have yung force ng Q1 on Q, okay, along the y-axis, plus FQ2 on Q along the y-axis. So this gives us Q1 on Q is along the y-axis is negative 0.173. So 0.173 newtons negative J hat, and then plus, then we have 0.173 newtons and then positive J hat. And this gives us 0. Okay, so 0. Now, makikita natin na 0 talaga yan based on dito sa figure kasi yung X component, yung Y components na ito, they are pointing in the opposite direction. So, magka-cancel yung dalawang vectors na yan since they also have the same magnitude. On the other hand, nag-add up yung dalawang X components, okay, kasi they point in the same direction and they have the same magnitude. Okay, thus, to get yung total, okay, na yung total na magnitude and direction, or magnitude and direction of total force, so gagamitin natin yung equation na ito. F is equal to yung yung sum, sorry, magnitude, okay, so yung magnitude ng force is just X component squared plus Y component squared and then square root. Okay. Since wala tayong Y component, it's just the X component, so we have 0.460 newtons. Okay, since this one is 0. Okay. Along the y-axis, yung ano naman niya, yung direction is given by this one, tangent inverse ng Y component divided by the X component. And since yung Y component natin is 0, yung tangent inverse niyan is 0. Okay, degrees. So, in other words, yung net in unit, yung net force points in this direction, okay, 0 degree na angle, okay, and has a magnitude which is twice, or which is the sum of this blue arrow and this pink arrow. Okay, so ito yung ating total force ngayon. Okay, and the magnitude is 0.460 newtons, and direction is 0 degrees. Okay. Questions? Okay, so again, yung mga first three problems, yung mga problems na sinolve natin the other meeting, first four problems pala, ay mga problems na nasa exercises, sample exercises dun sa book. So you can check against yung mga exercises na yun. Okay, now we're going to solve mga problems dun sa end ng chapter. Okay, so let's begin with syempre yung pinakamadali, which is number 1. Okay, naintindihan niyo naman ang ibig sabihin pag meron kayong double dot dito. Naintindihan niyo ibig sabihin niyan pag double dot, single dot. Naintindihan niyo ba? Thumbs up lang kung sasagot kayo ng hindi or thumbs down kung hindi niyo naintindihan. Okay, ibig sabihin lang yan, the more dots, mas mahirap. Okay, so this is an easy problem. This is a medium level na problem. Okay. So, yung number 1 actually is a medium level na problem. So, tignan natin kung bakit siya medium level. So, ang tanong dito is, excess electrons are placed in a small lead sphere, okay, with mass 8.00 grams. So that its net charge is negative 3.20 times 10 to the minus 9 coulomb. Okay, find the number of excess electrons on the sphere. Okay, and letter B, how many excess electrons are there per lead atom? Okay, the atomic number of lead is 82, and its atomic mass is 207 grams. Okay, so sa letter A, syempre ano muna yung mga given quantities. Also, always start with what you know. So, yung sphere na yan ay merong mass na 8 grams. And yung net charge is negative 3.20 times 10 to the minus 9 coulombs. Yung negative sign dito tells us na electrons yung mga energy dyan. Electrons yung excess charge. Okay. And then, ano pa yung given? Yung atomic number. It's 82. And yung atomic mass ng lead is 207 grams per mole. Okay, so sa letter A, paano approach natin dyan? Okay, so yung net charge is negative 3.2 times 10 to the minus 9 coulomb. Now, ang isang electron, okay, has a charge of 1.60 times 10 to the minus 19 coulomb. Okay, and then, syempre, negative yan. Okay? So, kung ang isang electron ay merong ganito karaming charge at ganito yung charge sa isang sphere, so ilang electrons meron? Okay, so gagawin lang natin simply to get the number of electrons, okay, is since meron kang ganito karaming charges, ganito kalaking charge, and per electron, you have this much charge, 609. 10 to the minus 19 coulomb per electron. And that means that yung number of electrons na present dyan is 2 times 10 to the 10 electrons. So, ganyan karami yung electrons na present pag ganyan yung charge. Okay. Now, sa letter B, okay, atomic mass niya is 207 grams per mole. And then you have, anong tawag dito? 8 grams, okay, na lead sphere. Okay. So, yung 8 grams na lead sphere will give us how many moles? Okay, so 207 grams per mole. So this gives us 0.038 moles of electrons. Okay. So per lead atom, so we have 0.038 moles. Okay. And alam natin na using Avogadro's number, 6.022 times 10 to the 23 electrons per mole. Okay. Alam natin na each lead atom will give us 2.29 times 10 to the 22 electrons. Okay. So here we used yung Avogadro's number. To determine yung excess number of electrons per lead atom. Questions? So remember, pag meron kayong tanong, just ask them. Okay, raise your hand or tawag dito or type yung questions nyo dun sa chat box. Okay, next. 21.2. Okay, so number 2. Lightning occurs when there is a flow of electric charge. Okay, and these electric charge are principally electrons. Okay, between the ground and a thundercloud. So the maximum rate of charge flow in a lightning bolt is about 20,000 coulombs per second. Okay. This lasts for about 100 microseconds or less. So how much charge flows between the ground and the cloud in this time? And how many electrons flow during this time? Okay, so it's important na intindihan nyo kung ano yung nangyayari dito. Okay, so kung meron kang mga clouds dyan, ito yung earth cloud. Okay, so yung lightning, okay, travels. Okay, but it's not actually the lightning that travels, but it's the electric charges that travels. Okay? And yung bilis ng pag-travel o yung dami ng charge na nagta-travel is 20,000 coulombs per second. Okay? So you have, every second you have that amount of charge flowing. Okay? But yung pag-flow ng charge only lasts for 100 microseconds. Okay, so how much charge flows between the ground and the cloud this time? So yung charge can simply be computed from 20,000 coulombs per second, okay, times the time, okay, na nagta-travel yung charge, okay, which is 100 times 10 to the minus 6 seconds. So this is simply 2 coulombs. And how many electrons flow during this time? Okay, so we can compute for the number of electrons. Okay, so we have 2 coulomb divided by 1.609 times 10 to the minus 19 coulombs per electron. Okay, so this gives us 1.24 times 10 to the 19 electrons. So, imagine nyo na sa isang lightning na bumabagsak from the cloud to the ground. In 100 microseconds na time, there's this much electrons na nagtatravel. Okay. Okay. So, yan palang easy na problem. Tapos ito yung medium level na problem. Okay. Sige. Ilang tanong? Di ba madali lang ang physics? Okay. Sige. Number 3. Lightning occurs, if a proton and an electron are released when they are 2.0 times 10 to the minus 10 meters apart. Okay, find the initial acceleration of the particle. Okay, so this is a different type of problem. Okay. Dito, meron kang electron at saka proton. So you have proton, which is positively charged, and an electron, which is negatively charged. Initially, okay, they are 2 times 10 to the minus 10 meters apart. Okay. And then, anong mangyayari sa mga electrons na ito? Mangyayari is they will attract each other. Okay. So once na i-release sila, that proton will get pulled towards the electron. And ganun din para sa electron. The electron will get pulled towards the proton. Okay, and they have merong force that describes yung pull na yon. Okay. Now, of course, pag merong force, ibig sabihin meron ding acceleration. Okay. So, ang gagawin ko ay wait. Papalitan ko muna ng kulay yan. And I'm going to use yung pink. Okay, para dito sa force na ito. Okay, so itong force na ito, na kulay blue, is the force that the electron exerts on the proton. And then yung force na pink is the force exerted by the proton on the electron. Okay? So, we know from Newton's third law na yung dalawang forces na yan ay equal lang sa isa't isa. So, from Newton's third law of motion, equal yung dalawang forces na yan sa isa't isa in magnitude. Okay, but they are opposite in direction. Okay, so equal sila in magnitude but they are opposite in direction. And we're going to write yung opposite na direction na yan using that negative sign. Okay. So pwede natin isolve yung magnitude ng forces na yan Okay, so, but first, anong kailangan natin dito ng mga quantities? Kailangan muna nating malaman yung charge ng electron. Okay, ang electric charge is 1.609 times 10 to the minus 19 coulomb. And this, of course, this is negative. Yung charge ng proton is also 1.609 times 10 to the minus 19 coulomb, pero yan ay positive. And since we're solving, we want to know the acceleration of each particle. We need yung mass ng electron, which is 9.11 times 10 to the minus 31 kilograms. And then yung mass ng proton, okay, which is 1.67 times 10 to the minus 27 kilograms. Okay. So let's solve first for the force. Okay. So in terms of magnitude, tawagin na lang natin itong F. Okay, kung magnitude lang din. Since equal naman sila in magnitude. So alam natin na ang force na yan is equal to K QE, QP, absolute value, divided by yung distance between them. So this is 9 times 10 to the 9 Newton meter squared per coulomb squared times 1.609 times 10 to the minus 19 coulomb squared divided by yung distance between them, which is 2.0 times 10 to the minus 10 meters. Squared dapat yun. Okay, so this gives us a force which is equal to 5.8 times 10 to the minus 9 newtons. Tapos, yung electron, so now we know the force. Okay. Ang alamin na lang natin yung acceleration. So yung acceleration ng electron, okay, is given by kung ano man yung force na yan divided by yung mass ng electron. So that's 5.8 times 10 to the minus 9 newtons divided by 9.11 times 10 to the minus 31 kilograms. Or this is 0.64 times 10 to the 22 meters per second squared. Okay. And yung mass ng acceleration naman ng proton is yung force na yan divided by the mass of the proton. So it's 5.8 times 10 to the minus 9 newtons divided by 1.67 times 10 to the minus 27 kilograms. And this will give us 3 times 10 to the 18 meters per second squared. And since acceleration is a vector quantity, kailangan natin i-provide din yung direction. So yung electron will accelerate in which direction? Well, hindi natin masabi ko anong direction because we did not define a coordinate system. So now I'm going to define a coordinate system and say na towards the right is the positive x direction. And based on this coordinate system na dinefine ko, yung electron ay mag-move towards the negative x direction, which means na I'm going to give the acceleration a unit vector na negative I hat. And then lalagyan ko na ng vector notation doon. Okay. And yung proton naman ay mag-accelerate in which direction? Towards the positive x-axis. So lalagyan ko to ng positive I hat and then ang unit vector ng vector na notation. Okay. So yan yung ating sagot. okay, for this problem. Any questions? Okay. Okay lang so far? Okay, so wala kayong questions. Okay, next. 21.7. So an average human weighs 650 newtons. Okay, if each of the if each of two average humans could carry 1 coulomb of excess charge, one positive and one negative, how far apart would they have to be for the electric attraction between them to equal their weight? Okay, so, na-imagine niyo ba yung nangyayari dito? So, merong dalawang humans, okay, and it just turns out na merong positive, na isang human is positively charged and yung isang human ay negatively charged. But both of them have the same amount of charge. So 1 coulomb of excess charge yung isang human, and then of excess positive charges yung isang human, and then yung isang human naman ay merong 1 coulomb of excess negative charges. So, dahil hindi tayo magaling mag-drawing, so, ganyan na lang ang gagamitin natin. Okay, so, okay. To be consistent sa ating equation, so we get this to be positive, then we use the blue color to be negative. Okay, so this human, ano ba ginamit ko dito? Okay, negative charge. Okay, so this human is negatively charged. And this human is positively charged. Okay, both of them have an excess charge of 1 coulomb. So lalagyan ko to ng negative na subscript and then to positive na subscript. Okay, so ang tanong dito is, gaano sila kalayo dapat sa isa't isa? Ano dapat yung distance between them such that yung force of attraction between them, okay, is equal to their to the weight of 650 newtons. Okay? So, given dito yung force, of course, 650 newtons. Okay, and yung charge, okay, given na rin yung charge na 1 coulomb. Okay. So we can actually solve for the distance, okay, using this equation. F is equal to K Q squared over R squared. Since we want to solve for R, we rewrite this as K Q squared over F. Okay, so square root. Or K over F square root and then lalabas natin yung Q. So this gives us 9 times 10 to the 9 Newton meter squared per coulomb squared divided by yung force na 650 newtons. Take the square root of that and multiply this by 1 coulomb. So this gives us 3,720 meters or 3.72 kilometers. Okay, so ganyan sila dapat kalayo sa isa't isa if yung force of attraction between them is equal to 650 newtons, is equal to their weight. So sobrang layo nung sobrang layo nung distance na kailangan. Okay, para lang maging equal yung tawag dito. Equal yung force of attraction between them sa kanilang weight. The farther apart they are, okay, yung force of attraction becomes smaller. Okay? And it becomes smaller real quick kasi squared yung squared yung quantity na yan. Okay, so if you pull them apart, okay, magdi-decrease yung force by yung square root ng R. Okay? But if you bring them closer, okay, and yung force of attraction na yun ay lalakas din by a factor of a square root of, or by in relation to the square root of R. Okay? So, in other words, okay, pag malapit na sila sa isa't isa, malakas na yung force of attraction. Okay. But we're talking about electric attraction, not that kind of attraction na malamang iniisip niyo. Tama ba? Okay. So, let's see. Dali na. Okay, so we have one more problem. We have time for one or two more problems. Okay, dali. Okay. Pwede naman natin isolve ito, pero itong problem na to, for some reason, hindi ko nailagay yung solution dito sa aking cheat sheet. So, anyway. Okay, sige. Ganito na lang gawin natin. Ito na lang i-solve natin na problem. Okay. So, 21.17. Last problem na i-solve natin in relation sa electric charge. And sakto just before mag-break. Okay. So, we have 2-point charges located on the y-axis as follows. Okay. So, at this point, mas maganda kung mag-drawing na tayo ng ating y-axis. Okay. Okay, so first of all, mapapansin natin na yung charges ay, ang location ng charges ay along the negative y-axis. So, yung axis na i-drawing natin ay ganyan. So, negative y-axis. Okay, positive x, and then ito yung positive y. So, yung first charge is located at negative 0.6 meters. So, 0, 1, 2, 0.3, 0.4, 0.5, 0.6. Okay. So, sabihin natin na yung charge Q1, okay. So, yung charge Q1, which is negatively charged, okay, ay dyan located Q1 ay dyan located sa negative 0.600 meters. Okay, at yung charge Q1 na yan ay merong negative 1.50 nanocoulomb. Negative 1.50 nanocoulomb. Then yung charge Q2 ay nasa origin and it's positive. So yung charge Q2 ay nasa origin and it's a positive charge. So Q2 is equal to plus 3.20 nanocoulomb. Located at the origin. Then ang tinatanong is ano yung total force, magnitude, and direction exerted by these two charges on the third charge Q3 located at y equals negative 0.4 meters. So ito yung negative 0.4 meters at nandiyan yung charge Q3 at yung charge niya is positive. So Q3 is positive 5.00 nanocoulomb. So it's positively charged. So ano yung total force na in-exert nung Q2 on Q3 at saka Q1 on Q3? Okay. In terms of magnitude and direction. Okay. So if we take a look again at the figure, yung Q1 is negative at yung Q3 ay positive. So ang gagawin ng Q1 is ipupull niya yung Q3 towards its direction. So this will be the force by charge 1 on 3. Now yung Q2 is positive and yung Q3 is also positive. So ang gagawin ng Q2 is ipupush niya. Okay. Ipupush niya, papalayo yung Q3. At yung force na yun is F2 on 3. It should be a vector quantity. Okay? So, dito pa lang sa figure, makikita na natin na yung net force, ang direction ng net force ay towards the negative x-axis. Okay? Ang kailangan na lang natin malaman ay yung direction, yung magnitude. So, we can now solve for the magnitude by first solving the magnitude of the total force, by first solving for the individual forces. So, yung F1 on 3 ay equal sa KQ1, Q3, absolute value, times yung distance between them, R13. So this is 9 times 10 to the 9 Newton meter squared per coulomb squared. Okay, tapos ang Q1 ay 1.50 times 10 to the minus 9 coulomb. And then ang Q3 is 5 times 10 to the minus 9 coulomb. Divided by yung distance between them. Anong distance between Q1 and Q3? Okay, so this is Q1 and this is Q3 and distance between them is 0.2 meters. And then square natin yan. Okay. Then okay, so sa notes ko hindi ko sinolve yung actual na magnitude yan, okay? But it's fine. Then solve naman natin yung F2 on 3. So this will give us Q, K, Q2, K, Q2, Q3. So R23 squared. So this is 9 times 10 to the 9 Newton meter squared per coulomb squared. Okay, times, ano yung Q2? 3.2 times 10 to the minus 9 coulomb times Q3, which is 5 times 10 to the minus 9 coulomb divided by, ano yung distance between them? So if this is 0.4, this is at the origin, then yung distance between them ay 0.400 meters squared. Okay, so kung ano man yung values ng mga to, okay, ay i-add up lang natin. Okay, it turns out na yung value na yan is, so yung total is 2.60 times 10 to the minus 6 newtons. Okay, by the way, yung F103 is along the y-axis pero towards the negative direction. So dapat lalagyan natin ito ng j hat. Negative j hat. So negative j hat. Yung force ng charge 2 on charge 3 is also towards the negative x-axis. So lalagyan din natin ito ng negative j hat. And that's why pag inad mo silang dalawa vectorially, in terms of magnitude, mag-a-add lang din sila. So yung lalabas na magnitude is 2.60 times 10 to the minus 6. And yung direction nila is towards the negative y axis. Okay, so again, this tells us that it's along the y-axis, and this vector points towards the negative y direction. Okay, so medyo straightforward. I hope straightforward yung solution. Clear ba? Okay, so ganito yung gagawin natin. Sige, ano yung question mo?
Hello, sir. I was asking if strict po kayo sa significant figures used for the final answer or throughout the solving process.
Hindi naman. Pero it's better if you tawag dito, follow yung significant figures. Pero hindi naman ako nagbabawas ng points. Lalagyan ko lang siguro ng mark na hindi siya tamang number of significant figures. Pero hindi kayo mababawasan ng points just for that.
Thank you, sir.
Okay, good. Any other questions? Okay, so I think we'll stop. No, hindi mo tayo mag-stop dyan. Mabilis lang. So, alam nyo na sa mga course requirements ay along with the exam ay meron mga quizzes, di ba? So, ang gawin natin is itong problem na ito, ibibigay ko na lang sa inyo as a take-home na quiz. Okay, which you will submit on Wednesday next week. Okay, magbibigay ako ng instructions. Okay, at ilalagay ko sa dun sa natin, sa chat natin sa Google. Okay? That's first problem. The second problem will be this one. Okay? 21.18. So this is an interesting problem kasi it's more practical. So you have two DNA molecules. Okay? And we want to see kung paano nila ina-attract yung isa't isa. And from this problem, you'll see na the attraction is actually electrostatic. Okay. Meaning na it's because of these static charges kaya sila na-attract sa isa't isa. Because of this excess charges na present kaya sila na-attract sa isa't isa. Okay, so ayusin ko lang tong instructions para sa quiz. Okay, and then I'm going to send it to you. Okay, kung paano niyo isa-submit and so on and so forth. Okay? Okay, kung wala ng questions in relation to this quiz, we'll take a break for now. Balik tayo ng 11:32, sabihin natin. Okay. So itong next concept na i-discuss natin ay yung tinatawag na yung concept on electric field. Okay, ang idea dito is this. So, dun sa mga examples na discuss natin earlier, okay, and then yung last meeting, di ba? Yung mga charges na to ay separated by a certain distance. Okay, and yung distances na to are not necessarily small. I mean, ibig sabihin not necessarily kasing liit nung sizes ng mga atoms. Di ba yung mga distance na inaano natin is 0.3 meters. And in one example, nakita natin na even 3.7 kilometers kung yung human, kung meron kang dalawang humans na separated by that distance. Okay. So at that distance, okay, I mean, sa tunay na buhay, di ba? If these two humans were the only humans, okay, na present sa Earth, okay, and they're separated by 3.7 kilometers. Okay, paano nila alam na yung isang human na positively charged ay tawag dito ay present? Okay, paano alam ng isang human na negatively charged na yung isang human na ang distance ay 3.7 kilometers ay present, okay, at that distance? Siyempre, realistically, hindi natin malalaman yan kasi kung halimbawa nasa isang sulok ka ng Baguio, then pumunta ka sa kabilang sulok, a distance of 3.7 kilometers, you will know na merong human dun sa kabilang side na yan. Okay. But it turns out na yung mga charges na ito, they do know na even with those distances, okay, alam nila na merong charge na present doon. Even yung 0.3 meter na distance, okay, is extremely large compared to their own sizes. Like yung isang hydrogen atom, for example, is about 0.5 times 10 to the minus 9 meters. Okay. And if they're separated, okay, if we have two hydrogen atoms separated a distance of 0.3 meters, how does one atom know that the other atom is there? Okay, if their distance is like 10 to the 9 meters apart. Diba? So, the only way for them to know that is meron something that connects them. Okay, and that something, okay, ay yung tinatawag natin na electric field. So, it is in this field, okay, where these charges are present. Okay, so if there's one charge there, okay, that charge actually creates an electric field. Okay. And yung direction ng electric field will actually depend on yung direction, on the sign of the charge. So if the charge is positive, then yung electric field na kinakreate niya ay away from the positive charge. If the charge is negative, then yung electric field na kinakreate niya is towards the negative charge. Okay. So para ma-appreciate natin yan, or para mas ma-visualize natin, ito yung tignan natin. So, tawag dito, here you have the positive charge. Okay, and yung point charge na yan ay nagpo-produce ng electric field that is away, okay, from the positive charge. Okay? Tapos, pag negatively charged naman, it produces an electric field that is towards the negative charge. Okay? So, that's how one charge knows that another charge is present even if they're a certain distance apart. Because these charges produce their own electric fields. Okay, so itong sinasabi natin dito is just the direction of the charge. What about the field? What about yung magnitude ng electric field na yan? Well, turns out na yung magnitude ng electric field, okay, decreases with increasing distance or increases with decreasing na distance. So yung electric field na yan is actually proportional as well dun sa square ng distance between the two, between yung charge na yon na nagpo-produce ng electric field at yung isa pang charge na present doon. So we call that other charge a test charge. Bakit siya tinatawag ng test charge? So ito yung idea dito. So we have two charges. Let's say na itong charge A at charge B. Now yung charge A na yan produces an electric field. Since it is positively charged, yung electric field na pinoproduce niya ay away from it. Okay? Now, if we want to know yung electric field at a particular position, maglalagay tayo ng isang test charge at that location. Okay? So, ito yung test charge na yun. Yung test charge na yun is also a charge, okay? But it's not, let's say na it's not really there. Okay, kasi test charge lang siya. We just want to put it there temporarily, okay, para lang malaman natin kung gaano kalaki yung electric field na yun. Okay? So yun yung idea ng test charge. Okay, so kumbaga, halimbawa gusto natin malaman yung electric field at this point, from this charge na nagpo-produce ng electric field, ilagay natin yung test charge siya. Pwede natin ilipat yung test charge dito if we want to know yung electric field at that point. If we want to know the electric field at this point, dyan natin ilalagay yung test charge. Okay, so yun yung silbi ng test charge. Okay, it's just, you don't include it in the calculations. You don't even need to know kung ano yung charge ng test charge. It's just there to sort of help you with the calculations for the electric field. Okay, so yung test charge na yan will, of course, feel yung electric field na yan, and it will know kung positive siya or negative. Okay, so if we put a test charge here, that test charge knows yung magnitude ng electric field, and it also knows kung positive or negative yung source ng charge. Paano niya alam? Kasi if it feels na yung electric field ay papalayo, it means na yung source ay positive. Pero if it feels na yung electric field ay paganyan sa direction na yan, then alam niya na negative yung charge ng source. Okay? So, ganyan na, yan yung silbi ng test charge. Now, yung magnitude ng electric field is given by this equation. Okay, so ito. And makikita ninyo na it's related directly to the electric force between yung source ng charge at saka nung test charge. So the electric field here is just the electric force between yung test charge at saka yung source ng charge divided by yung test charge. Now, even though dito nakalagay yung charge ng test charge, again, we don't really need to know yung charge na yun kasi we can just simply use itong equation na yan. Okay. Ito yung source nung charge, source nung electric field. Yan yung charge ng source ng electric field. Okay. So the electric force on a charged object is exerted by the electric field created by other charged objects. Okay, so that's how we know na merong charge doon kasi yung charge, yung test charge na yan feels this force. And if you divide that force by the test charge, then you get the electric field. Okay, so tawag dito, it's actually that simple, yung concept na yan. Okay, so in some sense, if we do problems related to electric fields, okay, it will be similar to how we solve yung mga problems related sa electric force. Okay? Ngayon, ang tawag dito, we can figure out yung itsura ng mga electric fields na yan, okay, by simply placing yung test charge, okay, at different locations. Okay, and that's, I think, yan yung gagawin nyo na isa sa mga experiments sa 102. Okay, so how is it going to happen? So if we have a single positive charge, alam natin na yung positive charge na yan ay magpo-produce ng electric field na papalayo sa kanya. But if we have two two charges which are oppositely charged, ganito yung electric field na mapoproduce. And if we have tawag dito, two charges that are similar yung charge, yung sign ng charge, ganito yung electric field na mapoproduce. Paano nyo malalaman yan? Well, again, ang gagawin nyo is lalagay kayo ng test charge at different points. At ganito rin yung gagawin nyo sa experiment. Okay, so meron kayong source ng charge na negative and another source ng charge na positive. And then what you're going to do is to put a test charge here, alamin kung ano yung tawag dito, electric force. Okay, divide that by the test charge. Put a test charge here, ganun din, test charge here. Okay, so maglalagay kayo ng mga test charges at different locations. Okay, and then makikita ninyo yung both magnitude and direction. Kung direction lang, ang gagawin nyo when you have mapped out, okay, different points, okay, dun sa experiment, makikita nyo na yung map na yon will give you this kind of electric field, okay, na direction. Similarly, ganun din yung gagawin nyo pag pareho namang positive or parehong negative. And makikita nyo na when you place a test charge at different locations, okay, you'll be able to map out yung electric field lines, okay, between these two similar charges. Okay, so again, yun yung silbi ng mga test charges. Okay. So they will make it easier for you to sort of visualize kung ano yung itsura ng electric field that is between charges. Okay. So any questions? So basically, yun na yung concept ng electric field. Okay. So now we can actually solve for problems, okay, related to this concept. Okay, so what is the magnitude of the electric field at a point 2.0 meters from a point charge Q equal to 4.0 nanocoulomb? Okay, so dito merong isang source ng charge. Okay. And we place a test charge somewhere here. Okay, at yung test charge na yan is a distance 2 meters away from the source. Okay? Kung magnitude lang yung pag-uusapan, wala pa yung direction. Okay. It's straightforward. Yung magnitude is just given by. Okay. Again, the equation. Okay. Ito lang yung magnitude dito. Okay. So you don't need to think about yung unit vector. So yung magnitude is given by K Q over R squared. Now, yung point charge na yan ay may charge na 4 nanocoulomb. Okay. So this will give us 9 times 10 to the 9 Newton meter squared per coulomb squared times 4 times 10 to the minus 9 coulomb divided by yung distance between them. So yung magnitude ng electric field is 9 newtons per coulomb. Okay. Ang unit ng electric field is newtons per coulomb kasi we get it from here. Okay. Ang force is newtons at yung charge is coulomb. So ang magnitude, ang unit ng electric field is newton per coulomb. Okay? So, yeah, yun yung medyo straightforward naman itong problem. Ito yung example na ito. Okay. Next. Okay. So itong point charge na ito, okay, so yung next example is about this charge. So a point charge Q equals a negative 8.0 nanocoulomb. Okay, is located at the origin. Find the electric field vector at the field point x equals 1.2 meters and y equals negative 1.6 meters. So this is the source of the charge. Source of the electric field, and it's negatively charged. And alam natin na pag negatively charged, yung direction ng electric field vector ay towards that charge. Okay, so yung electric field vector is pointing towards the negative charge. Okay, at that point P, okay, which is located 1.2 meters horizontally and 1.6 meters vertically, okay, along the negative y-axis. Okay, yung electric field na yung points towards the tawag dito, towards the negative charge. So pinapahanap natin yung electric field vector, which means that we're looking at both magnitude and direction ng electric field. Okay? Okay. So, ano ngayon yung approach natin dito? Again, tulad ng ginagawa natin before, solve first for the magnitude. Okay. So, anong magnitude dito? So, E is equal to K Q over R squared. So, ang magnitude is 9 times 10 to the 9 Newton meter squared per coulomb squared times again magnitude lang so absolute value, so 8.0 times 10 to the minus 9 coulomb divided by 2 meters, okay, and then squared. So this is 72 divided by 4, 36, 18. So this is 18 newtons per coulomb. Okay? Okay, so yun yung magnitude ng electric field. But, tawag dito, kailangan din natin malaman yung direction. Okay? And there are two ways to know that. Okay, first, we can tawag dito. First thing we need to do though is to determine yung x and y components ng electric field. So dito sa drawing na ito, yung electric field vector has an x component which points towards the negative x-axis and the y component which points towards the positive y-axis. Okay, now let's define this angle as the angle theta. Okay, which means that from geometry, this is also the angle theta. Okay? So yung x component ngayon ng electric field, okay, is given by yung vector E, by yung magnitude E times cosine ng theta. Okay, naintindihan niyo naman kung bakit cosine, ano? Kasi this will become a right triangle. So actually ito ay right triangle. Okay? And yung itong line na to, the adjacent line, okay, and the magnitude will give you cosine theta. Okay, so cosine theta is equal to, so ito yung x component and then ito yung y component. Cosine theta is equal to ey over e. Similarly, yung opposite side ng angle will give you sine theta. Sorry. This is x. Ey over. Okay, so kaya natin nakuha tong equation na ito for x and then similar equation for the y component. Clear ba yan? Okay, good. Okay. Then we just simply need to know yung cosine theta. To do that, we'll just use this triangle here. So itong triangle naman ang gagamitin natin. Oops. So ito yung angle theta na yan. Then we have this triangle na basis natin to determine yung cosine theta. So from there, yung cosine theta is equal to, ito yung angle na theta, ito yung hypotenuse. Ano yung hypotenuse natin? So base dito, it's 2 meters. And theta is adjacent over hypotenuse. So the adjacent side is 1.2 meters divided by the hypotenuse. Yung sine theta naman is opposite, which is 1.6 meters divided by the hypotenuse, which is 2 meters. Okay, paano nakuha yung 2 meters na yan? Okay, so, well, of course, it's given there sa figure. Pero if you're curious kung paano yan nakuha, medyo straightforward naman yan. 1.2 meters squared, 1.6 meters squared, okay. Then yung square root, that will give you 2 meters. Okay, so now we can solve for the x component. So this is 18 Newton per Coulomb times 1.2 meters divided by 2 meters. Okay, and this will give us 11 Newton per Coulomb. And then the y component is 18 Newton per Coulomb times 1.6 meters divided by 2 meters. This will give us 14 Newton per Coulomb. The only thing left to do is to add yung direction. Okay. So along the x-axis, yung electric field is pointing towards the negative x direction. So this will be negative I hat. And then along the y-axis, the electric field is pointing towards the positive y direction. This is positive J. And yeah. Okay. So yung electric field vector na yun is therefore given by Ex plus Ey, or 11 Newton per Coulomb negative I hat plus 14 Newton per Coulomb positive J hat. Okay. Okay. So ganito natin siya in-express, no? Kasi electric field vector, okay, yung pinapahanap. Okay. So it's not just the magnitude and the direction, but it's the vector that is being asked for. Okay. Any questions? Okay. Sige, next problem. Teka lang. Okay. So itong problem naman na ito ang isolve natin. Okay. Dito sa problem na ito, we have battery. We have a battery that is connected to two parallel conducting plates, as you see in the figure. Okay, so ito yung mga conducting plates. Yan. With a small gap between them. Okay, the resulting charges on the plates produce a nearly uniform electric field between the plates. Okay, so ang idea dito is this. So you have a battery, okay, na connected yung isang terminal sa isang plate at yung pangalawang terminal sa pangalawang plate. Since yung isang terminal is positively charged, itong plate na to will be positively charged. And then itong terminal na to is negatively charged. So itong plate na to will be negatively charged as well. And they're separated, okay, a distance of 1 centimeters. Okay. And since they're separated, hindi kayang mag-combine, okay, mag-combine ng positive at negative charges sa isa't isa. So they produce an electric field. And yung electric field na pinoproduce nila ay parallel. Okay. So paano naging parallel yun? Okay, so let me just try to explain a bit kung bakit parallel yan. Okay. And kung bakit dito sinasabi that they're nearly uniform electric field, which means na lahat ay parallel. Okay? Okay, so bakit naging parallel yan? Well, first of all, itong charge na to, magpuproduce siya ng electric field in all directions. Diba? Tulad nung inano natin, pinag-aralan natin earlier. Okay? This one will also produce an electric field in all directions. Okay? And it's the same story for each of these charges na yan. Okay, now, itong electric field vector na ito will cancel with this electric field vector na pinoproduce ng second charge. So, mag-cancel sila. Okay. Then, itong electric field vector na yon. Sorry. Okay. Yung y components nila ay magka-cancel. At ang matitira ay yung x components. Okay. Dahil pareho sila ng direction, mag-a-add up lang sila. Okay. So, madadagdagan ngayon yung yung vertical component. Ganun din para dito. So this, yung horizontal component niya will cancel with the horizontal component nito. Pero yung vertical component will just add up. Kasi pareho sila ng direction. So it turns out na lahat ng tawag dito, horizontal components ay magka-cancel. At ang matitira ay yung vertical components. And that's why inside this plates, puro parallel lang yung electric field. Okay, what about dun sa edges? Okay, of course sa edges, magkakaroon ka ng electric field lines. Okay, that will look like this. Okay, ganyan yung itsura. Okay, dun sa edges. Okay, bakit ganyan yung itsura? Remember, na ganito yung itsura ng positive charge. Okay? And if you have two dissimilar charges, ganyan yung itsura nila. Okay, so may curve, di ba? Curved yung electric field lines. Okay, from the positive to the negative. So at the edges dito, curved din yung electric field lines. But kung papansinin niyo mabuti, medyo hindi niya nilagyan ng edge yung plates. Okay? So sa perspective ng charge na ito, okay, these plates are extremely long na wala na siyang pakialam kung ano nangyayari dun sa magkabilang dulo. So hindi niya nararamdaman or negligible yung effect nung electric field dun sa edges. At ang nararamdaman niya nilang effect ay itong lines na ito. Okay? Yung electric field lines na parallel. Okay? That's why here, sinabi na nearly uniform na yung electric field lines. Okay? Okay. Although sabi rito, in the next section, we'll see why this is. Okay? Well, in-explain ko na sa inyo kung bakit siya ganyan. Okay? So, if the plates are 1 centimeters apart, okay, ano yung and are connected to a 100-volt battery, okay, the field is vertically upward and has a magnitude E equal to, magnitude E equal to 1.00 times 10 to the 4 Newton per Coulomb. So if an electron charge E has a charge of 1.6 times 10 to the minus 10 to the minus 9 Coulomb and mass 9.11 times 10 to the minus 31 kilograms, is released from a rest at the upper plate. Okay, what is its acceleration? And letter B, what is the speed and kinetic energy? What speed and kinetic energy does it acquire while traveling 1.0 centimeters to the lower plate? Okay, so in other words, naglagay tayo ng electric charge dito, which is negative. Okay, ano ang mangyayari sa kanya? Initially, 0 yung kanyang speed, mag-accelerate siya. Ba't siya mag-accelerate? Okay, at aling direction siya mag-accelerate? Well, since this is negatively charged, at nilagay natin siya sa negative plate, i-repel ng negative plate yung negative charge na yan. Similarly, na-attract siya dito sa positively charged na plate. So, hihilain siya ng positively charged na plate at itutulak naman siya ng negatively charged na plate dun sa direction ng positively charged na plate. Yung force na yon is given by this. Okay, kasi remember, this is a test charge at yung test charge na yan is simply an electron. Okay, na ang charge ay ganito. Okay, so ang force ngayon na nararamdaman ng electron na yan, so ito na yung letter A, is E, at least in magnitude, times E. So 1.609 times 10 to the minus 19 Coulomb times yung electric field na 1.0 times 10 to the 4 Newton per Coulomb. So F is therefore equal to 1.609 times 10 to the minus 15 newtons. Okay, anong direction ng F dito? Well, since hindi tayo nag-define ng coordinate system, hindi natin masasabi talaga in terms of vectors kung anong direction. So we have to define a coordinate system. So let's say na ang coordinate system na dinefine natin is such that ito yung positive direction, positive y. Okay, pinaliktad natin at typically, parati natin ginagamit na direction is na positive is upward, right? Ngayon, ang gagamitin natin is positive y downward. Okay, so this tells us na f will have a unit vector na positive j hat. Okay, now I just would like to emphasize one point. Okay, so define natin dito yung direction ng positive axis. Okay. And yung sagot ninyo will depend on that chosen direction. So, ang point ko lang dyan is, since nagtatanong kayo kung paano ako nag-check, okay, if you write down this answer without defining kung ano yung pinili nyong positive direction, okay, then ang gagawin ko is lalagyan ko yan ng question mark. Okay? Bakit? Kasi nowhere in your solution do I see any tawag dito, any chosen coordinate system. Naintindihan niyo yung point? So you have to choose yung coordinate system and you have to indicate kung ano yung positive na direction. Okay? For your answer to make sense. To me. Okay? Kasi ako yung nag-check, syempre. Okay, klaro ba yan? Okay? So, hahanapin ko to Hahanapin ko parati yung tawag dito yung coordinate system niya na pipiliin niyo. Okay, and I guess sa inyo din, sa inyo din mag-make sense din yan. I mean, kung hindi ko define yung coordinate system na yan, magtatanong kayo, bakit positive j hat yung nilagay niyan? Syempre, all the while, ang iniisip nyo ng positive direction ay pataas, di ba? So, ang tawag dito, tatanungin nyo rin yun malamang sa akin kung hindi ko define yung coordinate system na yan. Okay. So, yan. Okay. So, I define the coordinate system such a way na ang positive y direction ay pababa. Okay, so yan yung force sa letter A. Ang tanong is, ano yung acceleration? So the acceleration, nangyari. The acceleration is then given by yung force na yon simply divide by yung mass. So 1.609 times 10 to the minus 15 newtons plus j hat divided by 9.11 times 10 to the minus 31 kilograms. So the acceleration is then 1.76 times 10 to the 15 meters per second squared. Okay, and then positive j. Okay. Hindi ko napansin pero nag-define pala siya ng coordinate system dito. Okay, so meron pala siyang define na coordinate system. At ito yung coordinate system na dinefine niya. Okay, yan. Although dito, hindi niya sinabi kung positive or negative yan. Okay, so siguro mas clear kung lalagyan natin ng positive y dyan. Okay. Okay. Letter B. Ano yung speed and kinetic energy na na-acquire niya as a result of traveling a distance of 1 centimeters? So, ano yung given quantities dito? So, we know the acceleration and we know yung distance. Okay. So, ano ngayon yung speed na na-acquire niya from this point to this point? Okay. So, this is tawag dito, this reminds you of yung Physics 101 ninyo, diba? If you know the acceleration and you know the distance between these 2 points, then anong tawag dito, we can get yung speed, okay, at a certain point. So if yung speed niya at the origin is if it starts from rest, sinabi ba rito na ano? Ayan, sinabi rito, released from rest at the upper plate. Okay, so dun sa upper plate, yan, yung velocity is 0. So ang tanong dito is, ano ngayon yung velocity dyan sa lower plate? Ito na yung ginamit ko na coordinate system. Oops. Okay, so ang tanong dito is, ano yung velocity dito if yung initial na velocity at the origin is 0? So anong given? Given yung acceleration, given yung distance, di ba? So ito yung y naught equals 0 kasi galing siya sa origin, and this is y, which is equal to 0.01 meter. Okay, kinonvert ko na siya from centimeters to meter. Okay, and it's positive kasi yung direction ng positive y pababa. So for letter B, we can use yung kinematic equation na vy squared minus v naught y squared equal to 2a y minus y naught. So this is 0, this is 0, and this gives us vy equal to square root ng 2, oops, square root ng 2ay. So this is 2 times 1.76 times 10 to the 15 meters per second squared. Okay, and then yung distance na 0.01 meter. And then we take the square root of that. This gives us 5.9 times 10 to the 6 meters per second. Okay, tinatanong lang dito yung speed, so we don't need to take into account yung direction. What about yung kinetic energy? So yung kinetic energy is simply given by 1/2 mvy squared. So 1/2 times yung mass ng electron, 9.11 times 10 to the minus 31 kilograms times 5.9 times 10 to the 6 meters per second quantity squared. So the kinetic energy is equal to 1.6 times 10 to the minus 17 joules. Okay, now even though the exponent is small for these electrons, that's actually a really large energy. For that electron specifically, medyo malaki ang energy na yan. And kita nyo yung speed naman is 10 to the minus, 10 to the 6 meters per second. So that's a really high speed. If you recall, yung speed of light is 3 times 10 to the 8 meters per second. And according sa relativity theory, this is the maximum speed of any particle, okay, in the universe. Okay, so this is to the 8, this is to the 6, so this is only a fraction, about 1%, about 2% nung speed of light. So medyo mabilis na yan. Then sa letter C, how long does it take to travel this distance? So now we want to solve for the time. Okay, so gaano katagal yung travel time from this point to that point. Okay, and for that, we can use again yung kinematic equations natin, knowing yung initial velocity tsaka final velocity. Okay, so we can write it here. So C is equal to Vy, C, or Vy is equal to Vy is equal to V naught y, okay, plus A times T. Okay, we know Vy. Okay, we know that this is 0. Okay, we can now solve for the time. So T is equal to A, Vy over A. Okay, so Vy is equal to 5.9 times 10 to the 6 meters per second divided by your acceleration, which is 1.76 times 10 to the 15 meters per second squared. So yung time na to is 3.4 times 10 to the minus 9 seconds, or 3.4 nanoseconds. Okay, so just to give a picture kung ano nangyayari dito, we have an electron that is, we have a positive, an electron that's present here. Okay. Nag-accelerate siya towards this direction. The acceleration niya is 1.76 times 10 to the 15 meters per second squared. It started from rest. Pagdating dito, yung velocity niya is 5.9 times 10 to the 6 meters per second. And yung total na travel time niya is 3.4 nanoseconds. So yan yung nangyayari dyan sa ano na yan, sa electrons na yan, sa electron na yan, sa test charge. Okay? Okay. So, any questions? Okay, wait lang. So A, can we write the acceleration? So ang question is, can we write the acceleration as a negative value? Since although pa-upward po yung E, yung F po is downward, so F sub Y is negative. And since F sub Y is constant po, your acceleration should also be constant. First of all, yung F is constant, that's right, and acceleration is also constant. But to answer yung question kung ano dapat yung sign ng acceleration, again, I refer you back dun sa chosen na coordinate system. That's why it's important to choose a coordinate system. Okay, dito sa example, actually yung pinovide na yung coordinate system. Ito yung origin, yan yung direction ng positive y. And since yung force ay in this direction, in the same direction as the chosen positive y direction, then yung force mo is also positive. Okay? Which means na yung acceleration mo is also positive. Okay? So, if we already have this coordinate system, tapos sasagutin mo na ang F is negative at yung acceleration mo is negative, that would be incorrect kasi it's not consistent with the chosen coordinate system. Nasagot ko ba yung tanong mo? Okay, good. So again, in-emphasize ko lang na importante na pumili kayo ng coordinate system. Okay. Hopefully hindi ako magkulang sa pag-explain niya. Okay, any other questions? Okay, may nakita ako na nag-thumbs down kanina. Ba't ka nag-thumbs down? Okay, sige.